everyone, it's Alyssa and welcome to You Can Learn Math. Today is on dividing imaginary and complex numbers. Now, I'm mostly on the worksheets and things you're going to be doing in your classes. I pretty much can guarantee you're going to be doing more of the complex numbers, but we're going to start with dividing imaginary numbers to kind of ease you into that, not just throw you into the deep end. You know, I'm not that mean. So, one thing first. If imaginary and complex numbers, if you're not super confident with them, or you don't think you really have a good sort of grasp on what they are, please go to the links in the description below. I have a video there that's there about just what imaginary and complex numbers are, and also multiplying them. So if that's what you need help with, I have videos for you, just for you. So on to dividing imaginary and complex numbers. The way these are going to be presented, they're pretty much always going to look like fractions. I have never seen where they do something like 5 divided by 9i. It's never really written that way. If your teacher's doing it that way, then kudos. She or he is unique. But this is normally how you're going to see it. 5 over 9i, and they want you to simplify it. Now, unlike any other type of division, this is not usually going to look much different. It's usually going to stay a fraction. Your answer is going to be a fraction, which is why a lot of times, instead of saying divide, your instructions will say simplify, to let you know, yeah, it's still going to be a fraction. It's not going to get that different. What they mean then, you're like, well, if we start as a fraction and we end as a fraction, what's the point? This, my friends, this is the point. That 9i, a little darker so you can see it, that I in the denominator, in the bottom of that fraction, we cannot have it. It cannot stand. You cannot have the I in the denominator. Just like if it was something like 5 over square root of 8. Can't have a square root in the bottom. You can have it on the top, not on the bottom. You got to do something to get rid of it. So with this, i's can be in the numerator. They can't be in the denominator. I didn't make the rule. Don't look at me. But this is what they want you to do when you're simplifying. So first things first. As you may recall, when we put I to different powers, fun things happen. So I squared becomes -1. I cubed is -I. I to the fourth is +1. Again, if that doesn't ring any bells, link below, video below. Please make sure that you're comfortable with that concept. Okay, so for this to simplify it, got my concept over here. This is the big one, that I squared equals -1. To simplify this, I'm just going to multiply by I over I. So I divided by I is just going to be 1, just like any other number besides 0 that we're putting over itself. Like 5 over 5 is 1. Negative, 10,000 over -10,000 is 1. These are just ones. And if I'm multiplying by 1, I'm not changing anything. So what happens on top? I get 5 times I. And on the bottom, 9 times I times I. Well, I times I is I squared, right? And we just said I squared is -1. So 5 times I on top and 9 times -1 on the bottom. So we could say 5i over -9. And usually we would write that as the little negative out in front, -5i over 9. So far so easy, right? I have the hiccups. So try not to hiccup in your ear. Well, they're going to throw a wrinkle in it because of course they are. So here's the wrinkle that's going to come up really, really quickly. And it goes something like this. Let's zoom in a little bit. There we go. So negative 5 minus 3i all over 7 minus 10i. Oh, what do we do with that? Okay. I've got pluses and minuses, and just minuses in this case. I've got complex numbers. I don't have just imaginary numbers anymore. So what am I supposed to do? If I multiply this all by I, is that going to do anything? No, I don't think so. Here's what you do. You're going to, this is what happens, is you're going to do this every single time. This is what you're going to do every single time. You're going to look at this denominator and you're going to change this sign. 7 plus 10i. Okay? And then you're going to multiply it. You're going to put the same thing on top. So just like before, I over I, a number over the same number, it equals 1. So if I multiply this by 7 plus 10i over 7 plus 10i, it will equal 1. This whole thing equals 1. I'm multiplying by 1. I'm not changing anything. Why on earth would I want to do this? Well, it all goes back to something called difference of squares. Link in the description below if you'd like more information on this. But difference of squares is one of those things that you probably learn pretty early on in algebra, but then most students forget it and then it comes back to bite them again. There's quite a few concepts like this. Difference of squares, completing the squares. Yeah, it comes back and then they're like, but I didn't I didn't want to do this again. I'm sorry. This is what difference of squares is. If I have two numbers or constants or anything, and it's like a plus b times a minus b, and I do FOIL, link below if you don't know what FOIL is, or if you need a review on FOIL. You do FOIL, you multiply those together. Every single solitary time, you're going to get a squared minus b squared. The reason being, when you do FOIL, if you multiply everything out, you're going to get a squared plus ab minus b squared. Those two in the middle cancel out. This happens every single time. Why is this so helpful here? Well, let's see what happens when I multiply 7 minus 10i times 7 plus 10i. I'm going to use my knowledge of difference of squares because I'm fancy like that. A squared, or the 7, that's 7 squared, minus b squared, or b is 10i squared. I'm not going to deal with the top. I'm just going to look at the bottom now for a second. So what is that? 7 squared is 49 minus 10i squared. So 10i times 10i. That's 10 times I times 10 times I. So 10 times 10 would be 100. I times I would be I squared, or negative 1. So that's negative 100. So this is saying 49 minus a negative 100. There's no i's in there. Oh, yay! All the i's are gone. That's why we do this. Every single time it will get rid of the i's in the denominator. And that's why we're doing this. So on the bottom, that's what's going to be happening. Now on the top we are just going to do FOIL. We're going to multiply those binomials together. Negative 5 times 7 is negative 35. Negative 5 times 10i is negative 50i. I'm really writing this too big. Negative 3i times 7 is negative 21i. Wow, what happened with that? I. And negative 3i times 10i, negative 3 times 10 is negative 30. I squared is negative 1. Negative 1 times negative 30 is positive 30. Right, so I'm going to combine my like terms. Negative 35 and 30 is going to be negative 5. And negative 50i and negative 21i is negative 71i. So let me just tidy this up. Let me finish. The top is as combined as it can get, but on the bottom, 49 minus a negative 100 is 149. Okay, now I know if you're looking at that, you're like, how is negative 5 minus 71i over 149 more simple than negative 5 minus 3i over 7 minus 10i? Doesn't that look more complicated? Not to a mathematician. To a mathematician, the fact that the I is gone from the denominator is, so lovely. I don't like that. I don't like the I in the denominator. So whenever you have these, again, the key is always, always, always going to be doing that difference of squares on the bottom. So it doesn't matter what it is. Like say if it was, 52 plus 3i all over negative 75 minus 91i. I don't care. It doesn't matter what it is. The process you're going to follow is always the same. You're going to look at the bottom. You're going to change the sign in the middle. You're not changing this sign. You're just changing this middle from a minus to a plus. And then you're going to multiply it by the same thing on top because that's like multiplying by the number 1. It's going to cancel things out. And on the bottom, you're going to be left with this number squared, the A, minus this number squared on the bottom. And the i's will always disappear. If you do this, you multiply these two together on the bottom and the i's don't disappear, you've done something wrong and you need to go back. And even though it looks crazy, how you get at the end, when you have another fraction that frankly may look more complicated than what you started, it will be simplified. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.